In this video, we're going to explore how to create a test-driven design in a simple Java program. So right now, we have a program that is testing a simple vehicle. And we can see that it just says, okay, I'm going to add the odometer, gallons of gas, miles per gallon. I'm going to drive it 100 miles, and then I'm going to validate that the odometer is increased to 100 and the gallons of gas is decreased to 10. And that would work for a long time, but these days you might say, wait a minute, not necessarily, because I have an electric car or I have a hybrid car, and this model doesn't work, so what do I do? Am I in the wrong programming language? Well, the answer is no, you're not in the wrong programming language. You're in the right programming language. We just need to learn a little bit about inheritance, which is going to be our next lesson. But for now, what we can do is we can write a test that considers different iterations of these vehicles. Now, one funny thing, this is an example that I've used for many years since I started teaching computer programming around 2001. Back then, my cars were Neon, Cavalier, and Prius. And when I did this example recently, I thought, I bet nobody knows what a Cavalier or a Neon is anymore. Prius maybe, but not those. So I came up with a couple of new examples. One is Mustang, and the other is a Chevy Sonic. So a Sonic is a very basic vehicle, subcompact car, not a whole lot of frills to it, so our test will work for the Sonic. But when we consider a Mustang, it has a lot of things that a normal car would not have. One of them is the option for a convertible. So I put together a requirements document here, and we see that Ford Mustang is a vehicle. Therefore, everything we know about vehicle above still applies. But we have one more option, which is it can be a convertible. And this is a very simple test. Given a Mustang can be a convertible or not, when it is a convertible, then get convertible should return true. So that will be a very simple test. We can write that one pretty quickly. It gets a little more complicated when we consider a hybrid car. So I put some examples here about a Prius. So a Prius is a vehicle, so most of what's above still applies, but we do have to consider there's an exception, and that's when it's running off of electricity, not off of gasoline. The odometer will still increase, but the gallons of gas will not. So I added a few more requirements to this. Moving Prius can impact gallons of gas and or milliamp hours. A Prius gets 50 miles per gallon when using gasoline. When using gasoline, the milliamp hours increases by 1 for each 20 miles driven. Because keep in mind with a hybrid, it's charging as it's running. So, obviously it's variable, but for simplicity, I'm just saying, okay, let's use this formula. Well, now we can come up with a good given when then from that. And remember that given when then is part of behavior-driven design. And the whole idea here is that it's a language that everybody can understand. Because when we have input from multiple people and their diverse experience, we're going to get better tests because we're going to get more examples. So I've elaborated this into a given when then example, and we'll write a unit test from this. Given gallons of gas is 10, odometer is 0, charge is 4 milliamp hours. When vehicle runs 100 miles, then gallons of gas is 8, because 50 miles to the gallon, we've lost 2 gallons of gas. Odometer is 100, milliamp hours is 9, because we're saying that it charges 1 unit for every 20 miles it's driven. Now, we want to consider another case too. So if when using electricity, the milliamp hours decreases by 1 for each 25 miles driven, so basically 25 miles per milliamp hour. I have no idea if that's accurate, by the way. I've just tried to use some simple numbers here. When the charge is less than 5, the vehicle should use gasoline. If the charge is greater than 5, the vehicle should use electricity. So given gallons of gas is 10, odometer is, let's make that 100, and charge is 9 milliamp hours, when the vehicle runs 100 miles, looks like I have another correction here, then the gallons of gas remains constant. It's still 10, odometer is 200, and milliamp hours is 5. So basically we're running one test after the other, and we're running it both in internal combustion mode and in electric mode. Now, typically when we do behavior-driven design, we will have multiple examples per requirement. So we don't just want to consider the happy path. We want to consider things like what happens when it runs out of gas, what happens when it runs out of electricity, what happens when it runs out of both. Those are the reasons why we like behavior-driven design, because if we have 5 smart people in the room, they're likely to think of a lot of these edge cases, and we're going to have better coverage. But nonetheless, to make a nice, concise video, I just created 2 different test cases, one for Mustang, one for Prius. Within that, 1 test for the Mustang and 2 for the Prius. So given that, let's jump right in. I go to my project and I have vehicles test. I'm going to make a new class called Mustang test. So kind of a silly test here, but I've started with the @test annotation, and I've given this method a descriptive name. So convertible, really that's normally the method we're calling. We'll be calling get and set convertible, so I'll just say convertible. That's close enough. Then when convertible, it is a convertible. Okay, now let's do our given when then. So given Mustang can be convertible, when Mustang is convertible, then Mustang is a convertible. That matches pretty close, and not exactly, but close enough to the example that we've elaborated here. And that's what I mean when I say a good given when then example that we have in a requirements document can be a script for writing a test case. So let's go ahead and create these methods. Let's also create a Mustang object. Now at this point, of course, our test is going to break because we don't have a Mustang class just yet, but that's the whole idea with behavior-driven design. In the given method, we construct our new Mustang. In the when method, we set the convertible to true. And in the then part, we assert that Mustang get convertible will return true. Now, here's the nice thing about test-driven design. Everything that is read is something that we need to create. So our test is effectively done, provided I don't have any typos, which I might well have. But we can look at this and say, oh, okay, we've gone from requirements to given when then example to unit test. And now the unit test tells us what we need to do to write our program. So there's our Mustang. Let's go ahead and create a Prius test while we're here as well. So our given when then again matches the requirements document fairly closely. We say given gallons of gas 10, odometer 0, miles per gallon 50, charge 5. And that matches, oh, it should be charge, it should be charge 4. I'm glad I read that. When we run 100 miles, then gallons of gas 8, odometer 100, milliamp hours is 9. So our methods here match very closely to that given when then in our requirements document. Let's go ahead and fill out the details. So once again, you see this is similar to the test that we made for our vehicle, only now we're also considering a charge. Let's be consistent here. Let's go ahead and call it get charge. I would say get milliamp hours, but it's kind of a long and cumbersome word. So we'll just call it charge. That'll be easier. So you see this is very similar to the vehicles test I did in a previous video, only we're adding charge or milliamp hours here as well. Once again, everything that you see that's red indicates something that we need to build with our test-driven design. So we need a class name Prius. We need a setter method for gallons of gas, odometer, miles per gallon, and charge. We need a go method. We need a get gallons of gas, get odometer, get charge. Once again, this coming straight from the requirements document. This essentially becomes a series of steps to tell the programmer what to do. And it also helps to estimate the work that we have to do. So it kind of serves a couple different purposes. Okay, so that's a fairly straightforward case, and note that I did use the test annotation on top of our running with gas method. Now we also need to consider the case where the milliamp charge is high enough that it's going to run with electricity. Let's build that now. Now here's another neat thing about behavior-driven design. You see, if I repeat a step within a test, I don't have to create the same method all over again. So in both cases, I'm driving 100 miles. So in my go running with gas, I call when driving 100 miles, and it calls this method here. When I run with electricity, as I have the test set up, I'm still running 100 miles, so I don't need to create a new method for that. So in this case, we are validating that the gallons of gas has not changed from 10, yet the odometer has changed and the milliamp hour charge has changed from 9 to 5. Hopefully, all of my math was correct there because I did it mostly in my head. It is possible that we write a test that is not accurate, but there again, with several people giving examples, hopefully we'll catch that in the requirements phase. And the requirements phase is really the best time to come up with tests, because then we have the product owners in the room, we have everybody in the room who can make decisions, and we can verify with them, kind of give a second step verify and say, okay, this is what you want, by the way. So, trick right now is that this project is not going to build because our tests are broken. And that's how test-driven design works. When we get the project to build and the test to pass, we have met the requirements. Now, if we want, we can go to our POM, and we can use that excludes option within our build step to say, let's not run these tests just yet because we know it's behavior-driven design. Maybe somebody else is actually going to do the implementation, someone besides the person who wrote the test, so we want to commit it to GitHub. So we can use this configuration excludes and say, okay, we'll take out the Mustang test and take out the Prius test until we're ready. Well, nothing to build or show just yet because we haven't written those classes, so we'll go ahead and wrap this up for now. When we get to inheritance, we'll do a deep dive on how we can write classes that share things with other classes, but then also can override things from other classes and do things their own way. We'll see that in particular with the Prius, because we know it can run with internal combustion, it can run with electricity. So hopefully this gives you a little taste of what's to come. I hope this video is helpful, and I look forward to reading your comments. Thank you.